So you want to be an aerospace engineer. You get to work on vehicles that fly in the sky or in space, and these vehicles get people or resources from point A to point B. They help militaries defend against attacks. They also help with important operations in space. This is nothing short of extraordinary. So what are some of the positions that you may work in the aerospace industry? What's the day-to-day like? What kind of compensation and work-life balance can you expect? In today's video, we'll be discussing careers in aerospace engineering from someone who's worked in the aerospace industry for several years. Be sure to stick around to the end to get an idea of the various career paths that you could go into. So there's two main sectors that you may run into working in the aerospace industry. So the first is the defense sector, where you're building military vehicles, infrastructure to defend against attacks, certain types of satellites, missiles, or just anything you could think of that the military would use to monitor potential attacks, defend against them, whatever they need for their operations. So that's the defense sector. And that's the sector that you'll often need a security clearance for, which entry-level jobs, they'll sponsor you. Mid-level jobs, they may sponsor you depending on the needs of the position. It really depends. Be sure to look at positions to see the nuances for that. Civilian operations, there's commercial flight, a lot of what Boeing and Airbus do, medical transportation, cargo, communication satellites, science satellites. It's basically anything you could think of that's not military that would need to be flown somewhere or would require being flown in the sky or in space in order to accomplish whatever it needs to accomplish. And I would say there's also, in both industries, there's two main types of roles. So there's the design and development, where you're modeling out the product before it's built, whether you're modeling the mechanical or electrical systems, or modeling everything from a high level, what the mission is and such. And the product is planned out to satisfy certain requirements in this phase of the product development planning cycle. And the second type of role is when you're building, integrating, testing the product, whether it's an aircraft or helicopter or whatever it possibly may be. And this is the operations that are putting together the structures and the components of the product, and then making sure that it works properly, performing all these tests on it, whether it be a pressurization test for a commercial aircraft to make sure that the fuselage can maintain its pressure, and propulsion testing for propulsion components or propulsion systems to make sure they function properly, output what they need to, the reliability is what they need to be. And one thing to note is that these two are not necessarily mutually exclusive. Especially in smaller companies, you likely will dip into both of these in one single role because it depends on where a particular product is in its process. And you may be working on a number of different products, some of which are here, some of which are here. And even at bigger companies, I've experienced the same thing, where sometimes you're out on the floor, sometimes you're behind a computer doing all the planning and CAD modeling and such. So it could go either way. These are not necessarily mutually exclusive, but some positions are going to focus more on this, some positions are going to focus more on this. So be sure to do your research into your positions as you come across them and decide whether or not to pursue them. And so the kinds of mechanical engineering jobs in the aerospace industry, which people with mechanical degrees absolutely qualify for them, as well as people with aerospace degrees. So you could do mechanical design, which is all the CAD modeling and drawings, and this is geometric dimensioning and tolerancing to make sure that the dimensions of the part stay within their certain tolerances needed. And there's also something called tooling engineer, which is basically the design or evaluation of machinery that's used in the manufacturing process. And then structural analysis is the other side of design, where you're simulating all the loads on the structure and making sure it's not going to break or otherwise fail during tests, whether it be and during operations, whether it be an aircraft during flight or even during its own testing, and then performing structure and joint calculations to make sure that the two parts aren't going to separate and the joint's not going to fail. And you also will likely be overseeing testing and thermal analysis, similar to structural analysis, just dealing more with thermal loads and temperatures and temperature differentials and stuff, and likely be designing systems to make sure that heat flows around the product as well as it needs to and gets removed or added to the product as much as it needs to, and testing for these types of things as well. And then propulsion or other types of fluid systems, including like maybe even aircraft air conditioning systems for commercial aircrafts. But propulsion is going to be the big one, where you're modeling the fluid systems and CFD and testing of these propulsion systems to make sure they output what they need to and are reliable. And then there is like mechanical integration and testing, where you're dealing with overseeing and administration for mechanical assembly and mechanical testing of the finalized product. So emphasis in this case more on the mechanical side, whereas there is a similar thing for the electrical side, which we'll talk about now, because there's a few different things you could do as an electrical engineer as well in aerospace, because they're all going to need their electrical power systems where they collect their power from whatever source and distribute it to the various components, which for most aircraft, if they're not fully electrical, then they're going to get a lot of that power from, similar to a car, from just the engine running and then collecting power from that, as well as just from the sources that they got on the ground, and then distributing it properly to whichever avionic systems or just the starting up of the engines and whatever other needs electricity, and also the stuff just inside the cabin as well. And communications is another big thing, and not as directly dealing with circuits necessarily, but you're dealing with antenna systems, which you're going to need a circuit to supply electricity to it, but dealing with antennas and systems that communicate between the vehicle and the ground. So it'd be a system, for instance, mission control to communicate with the space station that's going to deal with these communication electrical systems. And then also like avionics, embedded electronics. So think like computer systems type of thing that are needed on aircraft or on satellites or rockets. And they may deal with data collection, processing, and computer hardware. So it's a similar kind of thing if you think about a modern car that tends to have a screen in the very front of it that you can do things on Google Maps. So that's an embedded computer that you use to get from point A to point B, know the directions and such. And there's other types of systems as well, like some modern versions of automatic transmission, or even a lot of some safety features that can detect cars in front of you and in the back of you and stuff. And so space vehicles and aircraft have similar things, these electronics that perform the embedded software for safety reasons or for whatever other performance reasons. And then speaking of which, we also do have the software itself. And so this is software programmed into a lot of these same systems we talked about with embedded electronics, avionics, and such, because these flight control systems or other related systems are going to have all these embedded software into them to make sure everything's performing properly. And so some electrical engineers may design the hardware, and some actually, because the software engineering, it's not like you need a computer science degree necessarily, because this is actually not to be confused with tech industry software engineering. That's very different. That's like websites or software as a service and stuff. And we're in this video specifically talking about software systems that are actually in aircraft or space vehicles and such that are used to properly carry out the operations of the vehicle. And so that is pretty specialized in the aerospace industry. So yes, you could absolutely do this as a mechanical engineering degree holder or an electrical engineering degree holder. maybe even a computer science degree holder. That's just not really their default career path. But this is absolutely a good cutting edge field to go into as well. And then there's also another one called systems engineering, which is similar to like project management or program management. And this is not to be confused with systems engineering in the IT world. That's very different. You're dealing at a high level with the product or the vehicle as a whole. So think about writing the requirements of the system, verifying they are met via analysis or testing, or whatever it may be. And so you coordinate with the various teams and disciplines and make sure everything's working together properly as a whole. And you're interacting a lot with other managers, with stakeholders over the project schedule and how everything's going, the performance and stuff. So think about like when it comes to coordinating with teams, you might be coordinating between the electrical engineers and the propulsion engineers when there's an interface between the electrical circuits and the propulsion fluid mechanics and such. If you have like a valve connected to a circuit and making sure that the two systems are flowing as they need to be. So that's going to be your job as a systems engineer, whether it be overseeing a test for that or communicating and coordinating between the two teams. And program management is often a career path that systems engineers go into because it is someone who oversees the entire project and managing cost, schedule, performance, and everything. And this is a career path that is growing. To be honest, it can definitely be boring and tedious at times because there is a lot of administrative work, sometimes grunt work, and dealing with requirements and verification can be pretty tedious. But one thing to keep in mind is that this does seem to be a pretty fast-growing field, especially in the aerospace industry, and so it could be good to consider for a work-life balance and such. And let's talk about quality assurance, and this is the one that arguably is maybe the most boring out of all of them, depending on the situation, and in aerospace it's a little bit different perhaps, but they basically ensure that everything's done right, done according to the procedures, and especially if you think about what quality assurance is in general, it's oftentimes like for companies that mass produce something, just making sure that there's very little variation between each individual unit. And in aerospace, there may not be quite as many outputs, quite as many high number of outputs of the same number of thing, at least in most cases. I mean, like Boeing outputs so many 737s, for instance, so quality engineers over there might be thinking like, we need to make sure that we're consistently providing the right quality of all the things needed in our 737s so that the pilots know how to use them no matter which particular unit they're actually operating. And then so, yeah, quality is the one just making sure everything's done right and that it's going to work as it needs to in the end. And so they do a lot of involvement in meetings and also making sure requirements are met, like systems engineers. They also get a vote in that. And so it's a lot of approving processes and approving the results of things and performing audits on the program to make sure everything's being done correctly. What is good about this career path is that it is really versatile because so many different industries use it. So even if you did this in aerospace for a bit, got the experience, and now you have actually a lot of other options of industries to go into. The problem is that it's actually pretty boring. But yeah, like I said, you can have a pretty good career path and pretty good upward mobility with this career path as well. Just make sure you know what you're getting into, and also it's just really not for everyone. But yeah, so that's what we've got for today. Thanks for tuning in. Be sure to hit the like button and the subscribe button on this video. Provide any comments or questions you have. Be sure to do your best. Good luck out there. Talk soon. Peace.